All right, before we get into solving quadratic equations, I think it's important that you understand what's going on in the graph when you're finding those solutions. And so we're going to kind of bridge the gap between those two using quadratic inequalities. There's two possible situations when we're talking about quadratic inequalities. One is where I still have my graphable function y, but instead of equals, maybe it says greater than negative 2x squared minus 4x plus 2. Okay, so just like the linear ones, we need to graph it, and then we're going to figure out if the line we use to connect the points is solid or dashed, and then are we going to shade upwards or downwards to cover the points that we're interested in. So I'm just going to sketch out x and y axis. And then because it's in standard form, I'm going to go ahead and just use negative b over 2a to figure out where my axis of symmetry is. So we're going to use negative 4 over 2 times negative 2 gives me 4 over negative 4, which is negative 1. So when I come out here to negative 1, axis runs right here, and then I'll take that negative 1 and plug it back in. Negative 2 times negative 1 squared minus 4 times negative 1 plus 2. Negative 1 squared is positive 1 times negative 2 is negative 2. Negative 4 times negative 1 plus 4. And then bring down the plus 2. So that just equals 4. So then on my negative 1, I'm going to go up to my vertex at 1, 2, 3, 4. Because this was already in standard form and I figured out my vertex, then I just come back to my y-intercept at 2, plot it, reflect it across, and I'm ready to connect my dots to draw my parabola. But I need to go back and check the symbol next to y to determine first, am I going to draw a solid line or a dashed line? This just says greater than. It's not greater than or equal to. So I don't want a solid line. We're just going to come back with a dashed line because it's just a boundary, right? These points that are on this part of the graph don't work in this inequality because the solid is where they're equal to. If I plug this back in, I'm going to get a false statement. And then I need to verify, okay, this is greater. So which way do we shade if y is greater? Well, just like linear, I'm going to want to shade up. But it's not quite so straightforward when we're dealing with a curve. So I'm going to go back to my points and draw what up from there would look like. And this helps us see that we're interested in everything that's outside of that curve. These are all of the ordered pairs that make sense when I plug them into my equation. Okay? It's pretty much exactly like the linear work we did. You just have to be a little more careful when you're determining direction. Okay? The next possibility is when I don't have a y, I have something that looks like x squared plus 9x plus 14 is greater than 0. Well, I don't have that y value anymore, so I'm not interested in shading a great area. I just need to know for this specific situation, what x values can I plug in that are going to give me an answer that's less than or greater than 0, and how do I find them? So we're going to sketch a graph. Okay? We're just going to lay out x and y. I know my y-intercept is at 14. I'm just going to call this 14. And then I need to find my vertex. If I use negative b over 2a, then I'm going to end up with negative 9 over 2 times 1, which is negative 4.5, which is fine. I can go in negative direction and call this 4.5 and draw my axis. When I plug that back in, negative 4.5 squared plus 9 times 4.5 plus 14 and I do the number crunch, I'm going to get negative 6.25. Again, I'm not trying to precisely plot this on a grid. I just need a sketch so I know what my basic shape is. It's under the x-axis, negative 6.25. We're going to put it right here. Right? And that's enough to give me a general idea of what just this side looks like if I graph it. And now what we're interested in is the places on here where it's greater than 0. So I'm going to go through, and first we want to point out that, hey, right here and right here, it equals 0. So I'm interested in these top parts of the parabola as they move away through there. Now the reason we sketched it first was so that we could easily see that both of my x values are negative. And at this point we're going to put it in our calculator, we're going to go y equals and look it up in the table, and we're going to find out that it hits 0 at -7 and again at -2. And I've already said I want everything this way. That's why we colored back over this part right there. So to write my answer for this, I just want to be really descriptive. I'm going to say that the x values to the left of -7, and I'm going to leave that unfilled, and I'm going to leave this an open circle because my original symbol didn't have an equal sign on it. And x can be anything to the right of -2. So this shows me everything I need. All of the x values that I can plug in are either less than -7 or greater than -2. Those are what I plug in here to get a value that's greater than 0. Okay. Last example we're going to look at is x squared minus 4x plus 5 is less than or equal to 10. So again, I want just a rough but accurate sketch of our parabola. Okay. I know that the y-intercept is happening at +5, so we're going to label that. If I look at this, negative b over 2a, negative 4 over 2 times 1, 4 over 2 is just 2. All right, we've got that marked. And then when I plug that 2 back in, 2 squared minus 4 times 2 plus 5, 4 minus 8 plus 5. 4 minus 8 is -4 plus 5 is 1. So my vertex is here. Reflect that across. There's my rough sketch of my parabola. This time, instead of 0, we're interested in where this graph is less than +10. So we're going to draw our line at what we'll call 10 because it's higher than the 5 and it's got the equal sign, so I'm going to put points here. I need to find out what these two values are. And because I have a reasonable graph, I know that one of my x values is negative and the other one is positive, which is going to make it easier to find those values in the table in the calculator. When I put this part in y1, I go to the table, I look for where y is 10, I'm going to find that it happens at x equals -1 and again at +5. And because this is less than, I'm interested in everything that now is under that line. And this time I have one connected piece of graph, so I need to make sure that when I write my answer, it kind of resembles that as well. Because now we're going to say that x is anything in between and including -1 and +5.